Okay. Continue with this section, numerical integration. We want to compute this integral. What we have about a function f, only this table. So, how to find this integral polynomial interpolation? Yeah. The polynomial that interpolate this table is in Newton's form. X1, no. This is a Q1 plus Q2 and degree n. Okay, so this is a xn. Qn. The error term is En. What is En? En is, let me see. Yeah. En. It is 1 over n plus 1 factorial derivative n plus 1 x some point psi x, and then times product x xi I from 0 to n. Okay, now in the last class. Oh, yeah. Therefore, this integral, I plot this equation here. Okay, then this is a integral AB polynomial. Then error term. Yeah. Drop the error term. Then we have a numerical formula to compute the integral. Drop the error term. Drop the error term. In the last class, we consider one special case. Okay, special case. Yeah. We obtain trapezoid formula, trapezoid rule. Okay, in the last class. Yeah. This is the last class. Trapezoid, right? Rule. Set x0 to be A. Yeah. X1 be B, right? AB. Then this integral on polynomial P easy to get. Then we have then we have integral roughly is B minus A over 2 F at A plus F at B. Yeah. Actually, the right side is area of some trapezoid. Okay. How good this approximation compute integral on the error? So equation, how good? This is yeah, here the error minus 1 over 12 second derivative at some point psi, then B minus A. Yeah. Error term. Yeah, this error easy to see that when, okay, in the case when B minus A is large, then the error is large. Right. When B minus A large, okay, say greater than 1, then error is large. Large. Say if B minus A is the length of the interval from A to B. Say 10 to the third, 1000. Okay. Suppose this derivative is moderate size. Say not too big, not too small. Okay, then this is error term. It's large. Right. Now, how to handle this case? Cut the interval AB into subintervals. Cut. Okay. Yeah. This is the same case. Apply trapezoid rule to each subinterval. Then we obtain composite trapezoid rule. Yeah. Composite trapezoid rule. Okay, now let me cut interval AB into subinterval. Okay, AB interval AB. A B. Okay. Let me call this A T0, then T1, T2, T3. Tn minus 1. Okay, this is B Tn. Okay. Cut. Then integral from A to B. Integral is area. Okay. Yeah. Cut the area from T0 to T1. And then T1 to T2. And so on. And then Tm minus 1 to Tn. Yeah. Apply trapezoid rule to each integral on the right side. This is what? This is AB B minus A. So T1 minus T0. Then over 2 function at T0 plus function at T1. Yeah. And then minus error. Okay. 1 over 12. Then second derivative evaluate at some point, say how about psi 1? Okay, what is psi 1? Psi 1 here. Okay, some point. Psi 1. Psi 1. Now plus here trapezoid rule here. This is T2 minus T1 over 2 F T1 T2. Yeah. And then minus error F psi 2. Psi 2 means okay. B minus A. Okay, don't miss. Okay, B minus A. T1 minus T0 to the. This is T2 minus T1 to the. And so on. Then here is Tn minus Tn minus 1 over 2. Function value Tn minus 1. Tn. Yeah. Then minus 12. Psi n. Right? Psi n. Yeah. Tn minus Tn minus 1. Sine n, yeah, some point, yeah, some point is sine n. Okay, now simplify. Right? I cannot simplify because because T0, T2 minus T1 may not be equal to T2 minus T1. I cannot simplify. How about let me make assumption, okay? All the subintervals, they have the same length, okay? Okay, how about, yeah, same length, yeah, here. Yeah, this is say H, H, H. Cut the interval AB evenly. Then I can simplify. Okay. Let H be B minus A divided by N. Then each subinterval, the length is H. From A to B, okay. Yeah. Okay. Okay. Now then this equation, which equation? Yeah, this equation. How about let me give a name to this equation, equation 1. Okay. Then equation 1 can be simplified. Okay. A, B is equal to, okay. T1 minus T0 is H. T2 minus T1 H. So H, right? So this is take out H. Say H over 2, take it out. Then it is F T0 plus F T1. Then plus, yeah, here. This is this, okay? Yeah. And then plus this. F T1 plus F T2. Yeah, yeah. And so on. Okay. Then F Tn minus 1. F Tn. Yeah. Right. Now error plus error. Error. 1 over 12 is common. How about here? This is an H, right? H. So I have 1 over 12 H to the third times, right? Times second derivative evaluate at psi 1 plus psi 2 psi n. Yeah. Continue to simplify. Yeah. H over 2. Here, right? I can see that F of T1 combined. Okay, so we have F T0 plus 2 F T1 plus 2 F T2, and then so on, plus 2 F T n minus 1 plus F T n. The error term I can also simplify. Okay, 12 H squared, okay, times B minus A over N. Yeah. F psi 2 psi N. You agree? B minus A divided by N. This is H. H times H squared. H to the, Now continue. B minus A over N. How about let me move N here, here. I move N here. N here. So this becomes B minus A. You agree? What is this? Function value at psi 1, function value at psi 2, function value at psi n. Take a sum, then take average. Average. So this is about this part. I can find some point sine. What is sine? Sine between A and B. Yeah. Between A and B, I can find some point sine. Second derivative at sine is equal to the average. Do you agree? So therefore, this is H. How about let me write FT0 summation I from 1 to n minus 1, okay? So F Ti, then plus, then minus B minus A over 12 times H squared times second derivative at some point psi. Do you agree? Constant. Log constant, but you usually disguise log big, log small. Okay. What is H? H can be arbitrary. Yeah. If I introduce more partition points to the interval AB, then H smaller. H is arbitrary. I can let H approach 0. Error. All right. Now, if I drop the error term, then I have a formula. This is a composite trapezoid rule. Yeah. The formula is again take integral AB. Roughly is here H over 2 F T n T0 2 summation I from 1 to n minus 1. This approximation is called composite trapezoid rule. How good this approximation is? Order 2. Yeah, this is a order 2. Composite trapezoid rule is an order 2 method. Order 2, very good actually. Yeah. So when H is 1 over 10, then order 2, 1 over 100. Very good. This is approximation, very good. Yeah. Yeah. In practice, people use this and also use an order 4 method. Order 5. The next special case is order 5. All right, now this is a special case. Okay, we choose x0 to be A, x1 to be B. Now the following method popular. Yeah, we often use. Yeah, popular. Right here. Second special case, number 2. It is called Simpson's rule. Simpson's rule. Usually we use Simpson's rule. Good enough. Okay. Here. Interval AB. Right? Now, interpolation polynomial. Set x0 to be A. X1 midpoint. Okay. A plus B over 2. This is x2. X2 is B. Okay. One more point. X3. What is X3? Arbitrary pick. Okay. Yeah. Here. Arbitrary pick. X3. This is an arbitrary. Okay. Arbitrary pick. X3 is according to my notes. What is X hat? Arbitrary. Okay. Between A and B, arbitrary pick of X hat as X3. All right. Then interpolation polynomial is polynomial degree. Let me see. Degree 3. Yeah. Degree 3. Then plus error term 3. Yeah. Then the polynomial is f. F x0, f x1, x2, then q1, f x1, x2, x3, q3, q2, then plus x1, x2, x3, x4. No, this is a x0, x1, no, x0, x1, x2, 0, 1, 2, 3, then q3 plus error. What is the error? Error term. Error. Interpolation polynomial. What is the error? N is 3, so 1/4 factorial 4th derivative sine x, then x minus x0, x minus x1, x minus x2, x minus x3. Yeah, error term. Yeah, error term. Yeah, error term. Yeah. All right. Error term. How about I denote error term by E3? Yeah, yeah. This is E3x. All right, now take integral. Right? Integral from A to B is equal to integral A to B on x0, x1, q1 plus f x0, x1, x2, q2 dx. Yeah. And then plus integral on this. Coefficient doesn't depend on x, constant, so I can move it up. Integral A to B, Q3 dx. Then error term, integral on error. Error. the first integral. Log are easy to get. What is that? The first integral. Let me see. First integral. Yeah. Remember, x0 is a, x1 is b term. Yeah, b term. x2 b. Yes. x2 is b. What is q2? Q2 we call x minus x0, x minus x1, q2. Yeah. So this is x minus a, x minus b point. This integral computable. It is b minus a over 6 f at a plus 4 f at b point. Then f at b. Yeah. Hey, now plus this. Yeah, here. Yeah, plus this. Yeah. Yeah. This come here, go here again. And then plus error. Error. Error, go here. Okay. Yeah. Hey, now let me compute this integral. This integral. Yeah. Yeah, Simpson's rule. Popular. Okay. Now let me compute this integral. Yeah, here. Take integral from a to b, Q3. What is Q3? Q3. X minus x0, x minus x1, x minus x2, Q3. Yeah, Q3. x1, b point. How about step x minus x1 is c, a new variable, change variable. Okay. x1, b point, b, a plus b. Then make change on variables. When x is a minus midpoint. What is that? A minus midpoint. 2. A minus midpoint. Here, this is a negative b minus a over 2. Yes. For c, okay, when x is a minus midpoint, that is c. When x is b minus midpoint. B minus a over 2. Yeah. Then how about this? Change variable x minus a. x0 is a. Then this is a c plus b minus a over 2. Yeah. And then x minus x1 c. And then how about here? This is a c minus b minus a over 2. Then dc. Yeah. Thank you. This integral is 0. Why it is 0? This function. Yeah. Yeah. This function is an odd function. Yeah. Let me see. This is x. Okay. This is a function. Okay. Function. Which function? Yeah. Function c minus plus b minus a over 2 c minus b over 2. Odd function. Odd function. A function is an odd function if function value at any point negative x is equal to negative fx. That is odd function. Yeah. Replace c by negative c. Negative c, negative c, negative c. Then this equation is true. Right. Now the integration in the interval is here. This is a negative b minus a. This is a b minus a. Yeah. Hey, this function, odd function, yeah, graph. Odd function. Integral net area. Yeah. Area above x-axis. Yeah. Yeah, Mark. Yeah, Mark. Yeah. Good. Yeah. Area above minus area below x-axis. 0. Okay. Yeah. This is 0. This is integral. 0. Hey, I have erased. Okay. Yeah. Actually, this term is 0. This is the error term. This is a AB. Yeah. This is a integral AB on Q3, right? On Q3. Yeah. This guy 0. Okay. Then Simpson's rule. Only the error term, the integral on error term, need to be computed. Okay. Yeah. Okay. Yeah. Integral AB f. Now is equal to b minus a over 6 f a plus 4 times f a plus b over 2, then plus f b. Yeah. Okay. Now this term 0, then plus integral on error. Integral a b on error. On error. Okay. Now next, I compute integral on error. Yeah. Okay. Now next, let me complete this. Okay. Complete this. Now compute integral AB error. We need to recall what is the error. Yeah, error is AB 1 over 4 factorial F4 sine. Some point depends on x, and also depends on x hat. Recall, at the beginning we arbitrarily pick upon x hat, so also depends on x hat. Yeah. And then times what? X minus x0, x minus x1, x minus x2, x minus x3. Yeah, integral. Hey. This equation Left hand side is a number, visit integral on function m. A constant, okay? Yeah. And also this part, a constant. So this guy should be constant. But in error, we see that this arbitrary pick, at the beginning, arbitrary pick, it turns out that this integral is a constant for any x hat. Any x hat, this is a constant. Yeah. What is x hat? X hat, x3, yeah, this guy is x hat. It turns out that for any x hat, then sign shift accordingly so that to keep this integral constant. Arbitrarily take x hat, say x hat, any point, okay, any point. Then sign this one depends on x hat, okay, accordingly. Yeah, pick a good sign so that keep the integral constant. Okay, now let x hat approach x1. Yeah, am I right? Yeah. Yeah, approach x1. Then error E3 is equal to AB 1, 4. Yeah. What is x1? X1 is midpoint. Okay, midpoint. Yeah. Okay. Now, after we take the limit, sign no longer depends on x hat. Yeah. And then here, x1. Okay, now x hat approaches x1. So this is a x minus x1. So x minus x1 squared dx. This is a A. Don't forget. This is a B. This is a midpoint. Okay, midpoint. B minus A. B plus A over 2. This product doesn't change sign over the interval AB. Let me see. When this is a A, this is a B, midpoint, B minus A. Let me see if X is here, this is an X here, then positive. Square, this is always positive. Negative, this is always negative for any X actually. Doesn't change sign. Yeah, say if X is here, then X minus A positive, then this is always positive, but this is a negative. Negative. How about if X is here? X is here, then X minus A positive, positive. X minus B still negative. So yeah, always negative. So we can move this outside the interval. The integral. Mean value theorem for integral. We have a theorem. Yeah. Go to take a look at my notes. Yeah. So I can move this outside. Okay. So I can find some point sign. Right? So that this integral is equal to this integral. X minus x0. X minus midpoint. X minus x2. Yeah. What is the integral computable? Okay, yeah, this is computable. This is what? Yeah, this is 1/4 factorial times this integral. This integral computable. So this is a negative f4 sine then over 2880. B minus A to the fifth. Okay. Yeah. Let me plot this result here. Okay. Yeah. Plot this result here. This integral is let me erase. I have compute integral and on error. It is negative 4A0 derivative 4 times, evaluate a sign, then B minus A to the fifth. Yeah. We get this equation. Drop the error. The approximation is called Simpson's rule. Simpson's rule. Yeah. Drop the error. Then we have Simpson's rule. Drop the error. Then Simpson's rule. Yeah. This formula, Simpson's rule. Same with trapezoid rule. When the interval AB is large, error is large. Yeah. Say 0, the interval is 0 to 100. Then B minus A is 100. 100 to the fifth, very large error. Now, how to handle a large interval AB? Cut the interval into subintervals. Cut. Okay. Yeah. A, B, Simpson's rule. It doesn't like trapezoid rule. Trapezoid rule for interval AB need the two endpoints A and B. Now Simpson's rule also need midpoint. Okay, now let me. This is a T0. Then T1, T2. Cut. Okay. How about cut interval AB into equal subintervals? Yes. T3, T4. Yeah. Each interval has the same name. Okay. So now T5, T6. Yeah. And so on. Okay. Okay. This is Tm minus 2, Tm minus 1, Tn is B. Okay, is B. Okay. Now apply Simpson's rule. Yeah. From here to here, because Simpson's rule, the midpoints. And also from here to here, Simpson's rule. And here to here. So we require n should be an even number. Yeah, should be even number. Right, now interval AB. Interval AB at integral AB is equal to cut T0 to T2. Yeah. And then T2 to T4. And so on. Yeah. And then T n minus 2 Tn. Yeah, n should be even. Okay, even number. Yeah. Okay. apply Simpson's rule, okay? Apply Simpson's rule to each integral and simplify. Then we get this is a h over 3. What is h? Again, h is a b minus a over n. Okay, n is an even number. Okay, now this is a function value at t0. T0 is 8. Then plus 2 times summation I from 2 to n divided by 2. N divided by 2. Recall n is an even number. So divisible. Okay. F T2I minus 2. And then 4. Summation I from 1. N divided by 2. F T 2I minus 1. Yeah. And then plus F Tn. Tn is B. Yeah. Then error. Error is what? What is error? Ah, here. Error. Error minus B minus A. H to the 4th. Yeah, H. The length of H subinterval. Then over 180 times the 4th derivative of N. Evaluate the sign. This formula is composite Simpson's rule. Okay, this is a composite Simpson's rule. Simpson rule. Composite Simpson's. Error term. B minus A constant. This guy not big, not large, not small. 180 constant. Yeah. H arbitrary. If you introduce more partition points, then H smaller. Yeah. We can make H arbitrarily small. Drop the error term. We have a formula to compute integral. The formula composite Simpson rule. Composite Simpson rule. Order is order 4 method. Trapezoid rule, order 2. Simpson's rule, order 4. Good? Very good. Okay, very good. In most of applications, Simpson's rule. In some special applications, Gauss's rule. Gauss's rule, even better. Okay. Now I finish here today.